Hi everyone, myself Satya, Department of Mathematics, SNS College of Technology, Coimbatore. In today's class, we are going to have the topic elastic membrane, which is going to, in this topic, we are going to incorporate the design thinking concept, which is going to innovate the flexibility. So the main thing is we are going to explore how the nature's flexible surfaces, which is going to inspire the innovation, which is done by human-centered design principles. Okay. Now the first thing is what is an elastic membrane? That is we should know. That is the basic thing, right? So elastic membrane, which is thin and flexible surface, which is going to deform under applied forces. We are going to give some force, right? After that, it is going to have some other shape, right? So but naturally, which is written to their original shape. Okay, so these remarkable structures combine the strength with capability. Okay, and what are the key properties are to remember? The first thing is elasticity, which means we are going to that is the ability to stretch and recover. The second thing is surface tension, which is maintaining the structural integrity. And the third thing is bending rigidity, which means we are going to resist the deformation while remaining the flexible case. Okay, there are three things you have to remember. The first thing is cell membranes, which means it is a biological barrier which is going to protect the cellular contents. And the second thing is mitochondria, which means it is the folded inner membranes maximizing the energy production. And the third thing is bat wings, which is the nature's elastic flight membranes enabling the agile movement. Okay, the next thing is yes, so which is the biological inspiration, the mitochondria's inner membrane. That is the thing we are going to see in this case. Okay, so the mitochondria's inner membrane are showcases nature's ingenious design solutions through indicate folds, which is going to call the crusty that elastic, which is going to increase its surface area by 4 to 10 times dramatically, which is going to boost the energy production efficiency, and 4 to 10 times. Okay, the surface area which is increased through folding, right? And the elasticity which is 100%, which is going to their original shape. Okay, and the next thing is how we are going to incorporate design thinking in elastic membrane. That is the thing we are going to see now. So design thinking, which is going to provide a structured but yet it should be a flexible approach to innovation, perfectly which is suited for developing the elastic membrane solutions that balance the technical requirements with user needs. Empathize. Okay, we know what are the stages in design thinking. Yes, there are 5 stages. One by one we are going to see now. Okay, the first stage is empathize. In this case, what is the thing I have to see? Yes, we need to take the user's perspective. So we are going to understand the user needs and we are going to observe how the natural membrane functions in biological systems. Okay, and this next thing is we are going to narrow down the problem statement. Okay, we need to identify the specific challenge in the membrane design. Suppose if it is flexibility requirements and the performance in the criteria. Suppose we are going to take this is the main problem we need to solve in that case. Okay, and the third thing is ideate. So here we are going to generate the diverse concepts for elastic materials, structures and novel applications. The third thing is prototype. Fourth thing is prototype. So here we are going to create some physical or digital models to test the membrane behavior and its properties. And the last thing is we are going to evaluate the performance, real conditions and iterations, designs based on the findings. Okay. So what is the case we are seeing here? So bad wing membranes. So bad wing, which is going to represent one of the nature's most sophisticated elastic membrane system, which is going to offer the valuable insights for engineering applications. So the things are natural engineering marvel and the elasticity balance. So in elasticity balance, we are going to research how it reveals the membrane elasticity critically, which is affects both lift generation and maneuverability, right? And too much of elasticity, which is going to cause the excessive deformation and energy loss, while insufficient elasticity restricts movement and it reduces the aerodynamic efficiency. Okay, the next thing is material innovation, which is going to create the elastic membrane prototypes. So the first thing is silicon sheets, second thing is elastic textiles. So in silicon sheets, it gives the high performance elastomers, which is going to offer the superior flexibility and by compatibility. And the next thing is elastic textiles. Here woven are knitted materials, which is going to combining the comfort with the dynamic stretch and the properties. Okay, the four things, which is laser cutting, heat sealing, layer bonding, fluxion method. Oh, these are the methods we are using, right? The next thing is computational design and fabrication. In this case, what is the thing we are going to do, right? Yes, which is the advanced computational tool, which is going to enable the inverse design of bending active strips that form the copies, right? So 3D freedom surfaces designers specify the shapes and the algorithm, which is going to calculate the exact that the pattern needed. Okay, and the four things, which is digital model, algorithm, fabrication, assembly. So the first thing is digital model, which means we are going to use 3D surface specification, and the next thing is algorithm. So we are to make the algorithm using inverse calculation of that pattern, and fabrication, which means we are going to precise the laser cutting in this step, and the next thing is assembly. So finally we are going to have the elastic bending into the form. Okay, so this is the visualizing part of design process. So empathize. So we are going to observe the biological membrane. Okay, and the next thing is we are going to frame, design the challenges and the requirements in this step. And the third step is we are going to brainstorm the material and the structural structures. And fourth one is we are going to build and test the physical needs. And the last step is testing, which is going to get the feedback and we are going to redefine. Okay. Okay. So, what are the challenges and opportunities you are facing? Suppose if you are incorporating design thinking concept in this topic. So, the first thing is elasticity paradox, and the second thing is scale translation. So, what are the applications we are using? Yes, there are three types of applications: wearable technology, soft robotics, and adaptive frigates. Okay, these are the things I want to remember. Okay, thank you.